Next, let's test what if the testing capacity changed. The graph here is for the 5,000 hours of testing capacity. Now, if the available hours are increased to 6,000 hours in testing line, then what should we do? We should first figure out the two intercepts corresponding to the new testing constraints. So this is what we are got here, those two blue dots. Okay, all right. Then based on that, okay, we can draw the new testing constraint line. It is parallel to the old one and above the old one. The outcome of shifting up the blue testing constraint line is that the feasible region is extended. So that means the current isoprofit line should be pushed up until it reaches the new corner point, B star. Okay, now B star is the new optimal solution when testing capacity increases to 6,000 hours and assembly capacity remains 3,000 hours. You can solve the corresponding numerical solution by working on these two constraint equations together. Still, you can see both resources are binding. Okay, now let's go back to calculate the profits from original solution and from the updated solution. It turned out by increasing testing capacity from 5,000 hours to 6,000 hours, the optimal profit is increased by $114 and $400. So in other words, in average, we can see that the profit increment to every 1 hour of additional testing capacity is $114.40. Pay attention to this number. This is a very important number to testing capacity, especially when we want to expand this capacity. We call this number as the shadow price of testing capacity. Shadow price is the opportunity cost of a resource. So the conclusion for increasing the testing capacity is the total profit will increase with the testing capacity by the shadow price. Now, currently our shadow price is $114.40. So if it costs $100 to add 1 hour of capacity in testing, what is your decision? Should you do the capacity expansion or not? The answer is yes, since you will benefit due to a higher shadow price. Actually, you will benefit by $14.40, which is the shadow price minus your expanding capacity cost, $100. Now, let's keep our experiment on the testing capacity. What if we increase it further from 6,000 hours to 7,000 hours? Then we know the blue testing constraint line will shifting upward further. It results in an even bigger feasible region. Okay, now we have to shift up, move up our isoprofit line until it touches the new corner point. That is our new optimal solution at which you can find both testing and assembly hours are fully used. And if you calculate everything out, you will see the profit is increased by another $114 and $400. Now we can conclude. Profit is increasing by the same shadow price of $114.40 per testing hour if increasing from 5,000 hours to 7,000 hours. Now, let's try to expand the testing capacity from 7,000 to 8,000 hours. When it is changed to 8,000 hours, the new blue testing constraint line is clearly above the old one. So the feasible region is further extended. Now, with this extended feasible region, we can push up the ISO profit line further to the new corner point, at which still both testing and assembly resources are fully used up. We can calculate the new optimal solution and find out that the optimal profit is increased by another $114 and $400. So we can claim profit is increasing by the same shadow price of $114.40 per testing hour if it is increasing from 5,000 hours to 8,000 hours. Now keep doing. Now let's increasing the testing capacity to 9,000 hours. The new blue testing constraint line shifts up, and the updated visible region will cover the whole triangle area below the green assembly constraint line. Correspondingly, we can push up the ISO profit line until it reaches the intercept on X1 axis by the assembly constraints, okay, which is still a corner point and is the intersection of the two resource constraint lines. The resulted profit you can find is one more $114 and $400 higher. Okay, now to this point, our conclusion is profit is increasing by the same shadow price of $114.40 per testing hour if it's increasing from 5,000 hours to 9,000 hours. It seems keep the same pattern, increasing pattern, right? Will this pattern remains further? This time, we increasing testing capacity to 10,000 hours. The new testing constraint line is totally above the green assembly constraint lines. It means the feasible region remains the same as when the testing capacity when the testing capacity is 9,000 hours. Hence, we cannot and don't need to move the ISO profit line again. Then, will the profit increase when testing hours increases from 9,000 to 10,000 hours? The answer is no, since the optimal solution remains the same as before. Notice, with 10,000 testing hours available, testing is no longer binding. Only assembly is fully utilized. So here is the conclusion from the sensitivity analysis on testing capacity. Additional testing capacity hour will improve the profit by the shadow price of $114.40 as long as the testing hour expansion is within 9,000 hours. If it goes beyond 9,000 hours, the shadow price will drop down to $0. No benefit to profit at all. Also, testing is no longer binding. At the optimal production plan, there will be extra testing hours remain unused. So we know shadow price will change, but when will it change? It depends on how big you change the resource availability. If the resource availability is changed so large that some previous binding resource becomes unbinding, or some previous unbinding resource becomes binding, then the shadow price must be changed.